Good day, everyone. My name is Vince Calberry Vistir. I am a first-year electrical engineering student from Central Philippine University. Today, I'm going to teach you two topics of integral calculus, which are the area and the volumes. In the area, we're going to solve for the area under the curve, the area between the curves, and the polar areas. For the volumes, we're going to solve problems using the disk method, shell method, and the washer method. Our learning objectives for the area are: use definite integrals to find the area between a curve and a non-horizontal or vertical line. Next is to use the definite integrals to find the area between the curves of two given functions, which are y equals f of x and y equals to g of x. Next, use definite integrals to find the area of a region bounded by more than two curves or lines. The principles of the area. Definite integrals can be used to find the area under a curve. They can also be used to find the area between two curves. To find the area between two curves defined by functions, integrate the difference of the functions. If the graphs of the functions are cross, or if the region is complex, use the absolute value of the difference of the function. In this case, it may be necessary to evaluate two or more integrals and add the result to find the area of the region. So the first topic is to find the area under the curve. What is the area under the curve? The area under a curve between 2 points is found out by doing definite integral between the 2 points. To find the area under the curve, y equals f of x between x equals to a and x equals to b. Integrate y equals to fx between the limits of a and b. This area can be calculated using integration with given limits. So the formula to find the area under the curve is that the area under the curve between 2 points is found out by doing definite integral between 2 points. To find the area under the curve, y equals f of x between x equals a and x equals b. So we are going to integrate y equals to f of x between the limits of a and b. So under the formula, there is a graph, and we're going to use this as an example for later in solving the problems. So we're going to solve two example problems. For example number 1, the given is the function of x is equals to f of x minus x squared. So the intersection is that f of x is equals to 0 and f of x minus x squared is equals to 0. So we're going to substitute. If f of x is equals to 0, 4 minus 0 is equals to 0. So the value of x are x equals 0 and x equals 4. Now we're going to solve for the area. The area with the limits of 0 to 4, the integral of 4x minus x squared dx. So the integral of 4x is equals to 4x squared over 2, and the integral of x squared is equals to negative x cubed over 3, with the limits of 4 and 0. Next, cancel out 4 and 2. So the answer is 2x squared. And copy the x cubed over 3. So x cubed over 3, we can also call it as 1/3 x cubed with the limits of 0 to 4. Now substitute the both limits to the variable. So 2 times 4, squared minus 1/3 4 cubed minus 2 times 0 squared minus 1/3 0 cubed. So cancel out this because it is equals to 0. So 2 times 4 squared, which is 16, minus 1/3, and 4 cubed is equals to 64 minus 0. So the final answer is 32/3 square units. Example number 2. The given are y equals to x cubed plus 2, y equals to 4, and x equals to 0. We're going to using intercept form, y equals to x squared plus 2. Put out x squared here. And so x squared equals to y minus 2. Square root it to get rid of the squared. So the answer is equals to x is equals to plus minus or positive or negative square root of y minus 2. So we're going to find the area. A equals to the integral of 4. The area of the integral of square root of y minus 2 dy with the limits of 2 to 4. So we're going to change the square root sign to 1/2. So equals to the integral of y minus 2 dy raised to 1/2 with the limits of 2 to 4. The integral of y minus 2 dy raised to 1/2 is equals to 2/3 times y minus 2 raised to 3/2 and with the limits of 2 to 4. So it's equals to 2/3 or 2/3. Substitute 4 to y. Then the quantity of square root of 4 minus 2 raised to 3 minus 2/3 or 2/3 times the quantity of square root of 2 minus 2 raised to 3. So is equals to 2/3 times square root of 2 raised to 3 minus 0. So the final answer is 4 square root of 2/3 square units. And this is the graph. This is the area that we solved, and this is the vertical strip. X is the distance from the vertical strip to the planes. Y is the height, and dx is the thickness. Next, the area between curves. To find the area between two curves defined by functions, integrate the difference of the functions. If the graphs of the functions cross, or if the region is complex, use the absolute value of the difference of the functions. So the formula of the area between the curves are, the area between two curves is calculated by the formula area is equals to the integral of f of x minus gx with the limits of a to b dx, which is an absolute value of the area. So this is the graph that we are going to use later and the formulas. We need to remember that. So example, the area between two curves. The given are x sub 1 is equals to y squared minus 2 and x sub 2 is equals to y. So this is the graph. So the intercepts so that we can plot the graph are y squared minus y minus 2 is equals to 0, meaning we're going to factor out y squared minus y minus 2. Then, using the intercept form, y minus 2 is equals to 0. So, y is equals to 2. If y plus 1 is equals to 0, y is equals to negative 1. Finding the area. Area is equals to the quantity of y minus y squared minus 2 dy from the limits of 1 to 2 is equals to the integral of y, which is 1/2 y squared. The integral of y squared is equals to negative 1/3 y cubed, and the integral of negative 2 is equals to 2y. It became positive because we're going to distribute the negative sign. So the limits from negative 1 to 2. So we're going to substitute the limits. So 1/2 times 2 squared minus 1/3 times 2 cubed plus 2 times 2 minus 1/2 times negative 1 squared minus 1/3 times negative 1 cubed plus 2 times negative 1. The answer is 2 minus 8/3 plus 4 minus 1/2 plus 1/3 minus 2 equals to 6 minus 8 cubed. 6 minus 8 over 3 minus 1/3 plus 2 minus 1/2 minus 4 raised to 1/2. I'm sorry. So 6 minus 8 over 3 minus 1/3 plus 2 minus 1/2 is equals to 4 and 1/2. So the answer is 9 squared, 9 over 2 square units. Example number 2. This is the graph that we're going to discuss later. So finding the intercept to plot the points, y equals to x squared, y equals to x plus 6, and x equals to 0. So x squared minus x minus 5 is equals to 0. If x minus 3 is equals to 0, meaning x is equals to 3. If x plus 2 is equals to 0, x is equals to negative 2. So the points are 3 and negative 2. So the area is equals to the integral of x plus 6 minus x squared dx with the limits of 0 to 3, because x equals to 0 and we have solved it, x equals to 3, plus the integral of x squared minus the quantity of x plus 6 dx with the limits of 3 to 5. So the integral of x is equals to x squared over 2 plus the integral of 6 is equals to 6x minus the integral of negative x squared is equals to negative x cubed over 3 with the limits of 0 to 3, plus the integral of x squared is equals to x cubed over 3 minus the integral of x is equals to x squared over 2, and the integral of negative 6, because we distributed the negative sign to x plus 6, is equals to negative 6x with the limits of 3 to 5. Now, substitute the value of the limits from x. So 1/2 3 squared plus 6 times 3 minus 1/3 times 3 cubed minus 0 plus substitute 3 and 5 to the value of x. So 1/3 times 5 cubed minus 1/2, 5 squared minus 6 times 5 minus 1/3 times 3 cubed minus 1/2 times 3 squared minus 6 times 3. So is equals to 9/2 plus 18 minus 9 plus 125 over 3 minus 25 over 2 minus 30 minus 9 plus 9/2 plus 18. So the final answer is equals to 157 over 6 square units. And this is the graph. The vertical strip, the distance, which is the x, the thickness is the dx, the height is y, and we labeled it as x and y. So x equals to 0, and the graph of y equals to x squared and y equals to x plus 6. So next, polar areas. The regions of the Earth designated as polar are those areas located between the North and South Pole and the Arctic or Antarctic circles, respectively. The northern polar region, called the Arctic, encompasses the Arctic Ocean and a portion of some surrounding land masses. So polar areas. To find the area between two curves in the polar coordinate system, first find the 2 points of intersection, then subtract the corresponding areas. So the formula for the area inside of a polar curve R equals to f theta. We start with the area of a slice of pi. If the slice has single theta and the radius r, then it is a fraction of theta 2 pi of the entire pi. So its area is equals to pi times 2 pi pi r squared is equals to r squared 2 pi. So we have some examples, 2 examples that we're going to solve. Find the area inside the inner loop, which is r is equals to 3 minus 8 cosine theta. So 3 minus 8 cosine theta is equals to 0. Cosine theta is equals to 3 over 8. So theta is equals to cosine raised to negative 1 times 3 over 8, which is equals to 1.1864. So the area is equals to the integral of 1/2 times 3 minus 8 cosine theta over 2 d theta with the limits of negative 1.18 and raised to 1.18. So next is to put out the constant 1/2 times the integral of 9 minus 48 cosine theta plus 64 cosine squared theta d theta from the limits of 1.18 and negative 1.18. Then copy. So 1/2 times the integral of 9 minus 48 cosine theta plus 32 1 plus cosine 2 theta d theta. The limits of negative 1.18 to 1.18. So substitute the value of the limits. So 1/2 times 41 theta minus 48 sine theta plus 16 2 theta is equals to 15.2695 square units. 15.2695 square units. This is the graph. So example number 2. Find the area of the graph of r equals to 7 plus 3 cosine theta. This is the graph. So the area is equals to the integral of 1/2 times 7 plus 3 cosine theta squared d theta. The limits of pi over 2 and 3 pi over 2. So put out 1/2. So equals to 1/2 times the integral of 49 plus 43 cosine theta plus 9 cosine squared theta d theta with the limits of pi over 2 to 3 pi over 2. So next, 1/2, just copy. 1/2 times the integral of 49 plus 42 cosine theta plus 9 over 2 times 1 plus cosine 2 theta d theta. The limits of pi over 2 to 3 pi over 2. Then 1/2 times the integral of, we're going to expand this. So is equals to 107 over 2 plus 42 cosine theta plus 9 over 2 cosine 2 theta d theta with the limits of pi over 2 to 3 pi over 2. Next, substitute the limits. So the answer is equals to 42.0376 square units. And this is the graph of the polar region. Our next topic is about volume of solid solid revolution. The learning objectives for volume. Students will recognize volume as an attribute of solid figures and calculate the volume of simple rectangular prisms by counting cubic units. The principles of volume. A solid of revolution is a three-dimensional object obtained by rotating a function in the plane about a line in the plane. The volume of the solid may be calculated by means of integration. Common methods for finding the volume are the disk method, the shell method, and Pappos centroid theorem or the washer method. What is the disk method? The disk method is the process of finding the volume of an object by dividing the object into many small cylinders or disks and then adding the volumes of these small disks together. So this is the formula for the disk method. The region bounded by y is equals to f of x, y equals to f of x, so x equals to a of x and equals to a. So in shorter term, the formula for finding the volume using this method is equals to pi y squared dx. So this is the graph. So pi times the integral of f of x squared dx from the limits of a to b. Example, find the volume bounded by the region as y equals to x rotated to the y-axis. So the graph is here. This is the area and the vertical strip, and this is the volume that we're going to solve. So the distance is equals to x, the height is equals to y, the thickness is equals to dx. The axis of rotation is on the y-axis. So the derivative of the volume is equals to pi y squared dx. So solving for the volume is equals to the integral of pi times square root of x squared dx, the limits of 0 to 4. So it's equals to pi times the integral of square root of x squared is equals to x squared over 2 with the limits of 0 to 4. We just substitute the limits and the final answer is equals to 8 pi cubic units. The next example, find the volume bounded by the region as f of x is equals to x squared minus 4x plus 5 as x equals to 1 and x equals to 4. So f of x is equals to negative x squared minus 4x plus 5. So this is the graph of the function. This is the area, the distance, the thickness, and the volume that we're going to solve. The axis of the rotation is on the y-axis. Again, the derivative of the volume is equals to pi y squared dx. Solving for the volume is equals to pi times the integral of x squared minus 4x plus 5 squared with the limits of 1 to 4 equals to pi times the integral of this multiply the exponent to the given. So x raised to 4 minus 8 x cubed plus 26x squared minus 40x plus 25 dx. So pi times 1023 over 5 minus 510 plus 546 minus 300 plus 75. So the final answer is equal to 78 over 5 pi. And that is our volume using this method. Shell method. The shell method is a method of finding volumes by decomposing a solid of revolution into cylindrical shells. Consider a region in the plane that is divided into thin vertical strips. If each vertical strip is revolved about the x-axis, then the vertical strip generates a disk, as we showed in the disk method. So the formula for the shell method is equals to a similar process with a cylindrical shell with height h, the thickness of x, and approximate radius r, cutting the shell and laying in flat forms. A solid of length of 2 pi r, the height and depth of dx. So the volume is equals to 2 pi r h dx, or 2 pi times x y dx. So these are the graph, and we're going to discuss this later on our examples. So for the examples, find the volume bounded by the region y equals to x times x minus 1 squared rotated on the y-axis. If x times x minus 1 squared is equals to 0, so x equals to 1. So this is the graph. I'm sorry if it is not the same. So the axis of rotation is on the x-axis. So the distance of the axis of rotation and the graph is equals to x. The height is equals to y. The thickness is equal to dx. And this is the volume that we are going to solve. So the volume is equals to the integral of 2 pi x y dx. Substitute is equals to the integral of 2 pi times x times the quantity of x minus 1 squared dx. The limits of 0 to 1. So put out 2 pi. So 2 pi times the integral of x raised to 4 minus 2x cubed plus x squared dx. The limits of 0 to 1. substitute 2 pi times the integral of x raised to 4, which is equal to x raised to 5 over 5 minus 2x cubed times the integral of that is equals to 2 times x raised to 4 over 4, and the integral of x squared is equals to x cubed over 3. And we're going to substitute the limits 1 and 0. So the final answer is equals to pi over 15 cubic units. So example number 2. Example number 2. Sketch the region bounded by y equals to square root of x equals 4, and y equals to 0, rotating on the y-axis. So this is the graph. So x equals to 4 and y equals to 0. Rotating on the y-axis, so this is the image. And we're going to solve the volume of this. So the derivative of the volume is equals to the integral of 2 pi xy dx. So volume is equals to the integral of 2 pi x, substitute square root of x from y. So 2 pi x times square root of x dx, the limits of 0 to 4, equals to the integral of 2 pi x raised to 1/2 dx. So 2 pi integrate. So 2 raised to 5 times x raised to 5 over 2 times the limit of 0 to 4. So 4 pi over 5 times 4 raised to 5 over 2 minus 0 equals to 4 pi over 5 times 32, because 4 raised to 5 over 2 is equals to 32. So the final answer is equals to 128 pi over 5. So this is the answer, and this is the graph using shell method. Washer method. A method of computing the volume of a solid of revolution that is hollow about its axis by integrating over the volume of infinitesimal washer-shaped slices bounded by planes perpendicular to the axis of revolution. So the formula for washer method. The outer cylinder has radius ry and its volume is equals to v outer times pi ry squared v. So in other words, the volume is equals to the limits, the integral of pi times b squared minus b minus y squared dx with the limits of a to b. And this is the graph. This is the washer, and we're going to graph it later. Washer method. Find the volume of a solid obtained by rotating a region bounded by y plus secant x, y equals to 3, and y equals to 1. So this is the graph. So the graph of 1 plus secant x is this one. And put in some vertical strip. Then create a graph of for the washer method. This is the washer. We labeled the points pi, negative pi over 3, 3, and pi over 3, 3. So washer method, the thickness is equals to dx, the axis of rotation, the height of the inner circle is labeled as y sub 1, and the height of the outer circle is labeled as y sub 2. So the derivative of the volume is equals to pi y squared, pi y sub 2 squared dx minus pi y sub 1 squared dx. So the volume is equals to integral of pi times 4 plus secant squared x dx. The limits of 0 to 3. So we just added 2 because we are going to use it because it is a symmetric rule. So 2 pi times 4x plus the integral of secant squared x is equals to tangent x, and substitute the limit pi over 3 and 0. So the final answer is equals to 2 pi times 4 pi over 3 minus square root of 3. This is the answer using Washer method. So example number 2. Find the volume of a solid obtained by rotating a region bounded by x equals to y squared, x equals to 1 minus y squared, about x equals to 3. It is rotated on the y-axis. So the graph, this is the washer. We use the horizontal strip, this is the area, and we're going to solve. So we first find the area. So pi is equals to big R squared minus small r squared times dx. So pi is equals to pi times 3 minus y squared minus 2 plus y squared squared. So pi times 9 minus 6y squared plus y raised to 4 plus plus negative 4 minus 4y squared minus y 4. So the area is equals to pi times 5 minus 10y squared. Now solving for the volume, v is equals to 2 times pi raised to the square root of 1/2 0. Again, v is equals to 2 times the integral of pi times 5 minus 10y squared dy with the limits of 0 to square root of 1/2 equals to 2 pi times the integral of 5 minus 10y squared is equals to 5y minus 10y cubed over 3, and the limits are 0 to square root of 1/2 equals to 2 pi, substitute the limits, 5 times square root of 1/2 minus 10 times square root of 1/2 over 3 squared minus 0. So solve 10 pi times square root of 1/2 minus 2 times square root of 1/2 cube over 3 is equals to, the final answer is 10 square root of 2 over 3 pi. And this is the washer method. Thank you for listening. I hope you learned something, and see you again next